Well, good morning my fella 3 feet tall bunnies. I got an art block while working on a VRChat world, so I decided to do this while my brain is trying to generate something. Today I'll explain Unity shaders and its structure. By the way, I might get a bit spicy with some personal opinions. Don't blame me, blame the VRChat girls. Now with that cleared, prepare your booty. As I said on my previous video, the process of rasterizing shaders consists of 2 phases, 3 if you feel daring today. The vertex program, where for each vertex you input its data and calculate a new set of values that get output for later use. Then the fragment shader that calculates each pixel where the model is present, outputting its result to the buffer. Now you might be asking, yeah, this shader thing is cool and all, but tell me stereo. How are you? How do you feel? Do you have any problems? Remember, I am here for you. We are all going through a lot of bad moments, but they will eventually go away. Take some rest. Remember, I love you. My happiness depends on yours. Now I'm totally fine, not like I have been going through 7 existential crises for like a year. Now let's get into Unity. What a nice sky, am I right? But it can be better. Let's get 3D mode. I'll put some calm skybox to get good lighting. This one specifically is called Pfalzer Forest. You can find a lot of high quality HDR and EXR skyboxes on polyhaven.com, previously known as HDRI Haven. By the way, this is not a sponsor, I am serious with this. Support their Patreon if you want. They have been very helpful for my Blender and Unity stuff. Now let's get down to business. Now that we are actually on a Unity scene, let's add a model to pre-visualize the shader. A Susie for example. A Suzanne for example better said. You can see I made one half of the model smooth and another half sharp. I guess I don't need to explain why. Right now the mesh is using the Unity built-in standard shader since there's no specific material assigned onto the model. Let's create a new one. Right-click the project window and create a new shader. You'll see you have various options. It won't be a ray tracing shader since I want my GPU to survive. These 2 I don't know, and a surface shader is just a customizable standard shader, so the shader we want to write will be unlit. To create a material do the same, but instead of shader, click material, set the materials shader to the one you created and then drop it onto the model. Now the model is, as the shader says, unlit. Let's see the code. What an interesting structure, right? Let's break it down. We start with the main shader, that will be the entire file. Inside there are 2 programs, properties and subshader. The properties are optional. It's used to manipulate parameters inside of the subshader. The main variable types you can use are float, integer, color, range, vector, 2D texture, 3D texture and cube map texture. A float is a 32-bit variable useful for very small values. The comma doesn't have a specific position. An integer is also a 32-bit variable. It can only have whole numbers. A color is, as its name says, 4 variables, being the red, green, blue and alpha channels. These variables are fixed, that means it will have a comma like a float, but it won't vary its position depending on the scale of the number. A range is a float value that varies between 2 specified numbers. It can be adjusted with a slider. A vector is a group of 4 floats, while a color is also made of 4 comma values. A vector can range to values greater than 1 and it must be written axis per axis. 2D textures are basic 2-dimensional images. Their pixels are coordinated in 2 axes. A 3D texture is a 3-dimensional matrix of pixels. This texture, in difference of the 2D texture, cannot be read outside of Unity since holograms do not exist. Lastly, a cube texture is a 2D texture wrapped in the shape of a sphere. Its pixels can be accessed with U, V and W axis. These properties are declared as it follows. First, the name it will have in the shader, starting with an underscore. Then between parentheses the display name is written as a string. After that, still on the parenthesis, there's the type. Closing the parenthesis, the default value is set with an equal. The default values for integers and floats will be just a number of their type. Colors and vectors will both have their default values as 4 numbers between a parenthesis, and textures will have a string that represents a color followed by opening and closing brackets. These strings can be white, black, gray or bump. There are actually more, I just don't remember them. Now to the subshader. Before showing what's inside, let me clean it up a bit. Inside of the subshader you declare the passes. A pass is the phase where the model is read, calculated and rasterized. That way you can use multiple passes to process or blend additional shaders like an outline, a shadow caster, additional lights or a fur. Lights or a fur. Lights or a fur. Lights or a fur. Lights or like a melody in my. On the pass you write the shader program I talked about on the past video. This program is started with the keyword CG program and finished with the keyword endCG, to specify the vertex program and fragment program. You have to pragma the keywords vertex and fragment, each one followed by the names you'll call them on the shader. After that we can start writing the shader. First of all we declare the vertex input and output structures. The input structure will use the vertex position and texture coordinates. Float 4 means it will be a 4-axis float vector, in this case x, y, z, will be the position, and w will be needed to correctly calculate 4x4 matrices. Then text coord 0 will be a 2-axis texture coordinate vector. The last number indicating the index on the list of texture coordinates, since you can have more than one. Then the output structure will return the position the vertices will have on the screen. It always has to be identified as SV_position. It will also return the texture coordinates because we'll need it for the fragment program. Before starting the programs, I recommend declaring the properties that have been created back on the properties section. In this case we only declared a 2D texture named main_tex. So we will declare it on the CG program as a sampler 2D. It can also be declared as a texture 2D, but I'll explain this on the next video. Now on the vertex program, the variable the function returns has to be the output structure. As I said on my previous video, the name of the function is to be exactly the one you called on the pragma, and its input will be the vertex input structure. The function unity object to clip pose always has to be present to assign the output position, otherwise your model will appear static covering all of your screen. For the UV we don't need to do anything in here, so we'll just return it as it is. Once we assigned all of the parameters on the new structure we can return it. Now the vertex program will be initialized the same way, in difference that it will return a fixed 4, meaning that it's a 4-channel pixel. Inside we will sample a texture with the function text2D. The first parameter of the function is to be a sampler 2D, and the second will be the coordinates. To make it easier to understand, if you multiply the coordinates by the texture's resolution, you'll get the pixel identifier. The texture coordinates always range from 0 to 1 because a texture's resolution is always different from another's, so keep in mind this multiplication is an example and you don't have to do it. Now we just need to return this texture, and also finish the CG program, the pass, the subshader, and the shader itself. Now let's assign a texture on the material to see how it looks. To do that, drag and drop the texture onto the slot or click the circle next to it to open a selection window. Well, wow, don't say you didn't expect it. You can always try with actual textures like wood or stone, but it looks very flat. Obviously, it's only returning a texture, doesn't have extra maps nor lights. With that said, thanks for your attention. I hope you learn more with my following videos and get to make your own shaders, that way you can do your cool stuff and I can keep my FPS. Goodbye.